real area of expertise is in soil health and environmental services of agroecosystems. Now, he publishes project reports, I know Ken referred to that, and submits to peer-reviewed manuscripts for Farming Smarter programs. Always an extra great way of getting some credibility. His master's in soil science comes from the University of Delaware, and his postdoctorate and PD programs both at the University of Saskatchewan studied soil organic matter dynamics and sequestration using synchrotron-based spectroscopic techniques. Try saying that fast 3 times in a row. But anyway, it's great science, and we look forward to hearing what Gurbir has for us today.
Thanks, Diane, and thank you everybody for being here. I'm going to be talking about some of the research projects that looked at some promising agronomic practices, including precision planting or row crop planting in crops like canola and pulses, and also deep banding of immobile nutrients. So to start with the precision planting, the precision planters, they help with the precise placement of seeds within the seed rows. So they help to reduce the interplant competition. Generally, the conventional air seeders, they use air pressure to force the seeds out of the seed run and into the field, and that can lead to irregularities in spatial distribution of seeds. With the precision planter, we use the vacuum pressure instead of air pressure. The picture on your right is showing a vacuum plate. It has a series of holes, and when it passes through the seeds, the vacuum pressure attaches those seeds to the holes, and then when it rotates, it is able to drop one seed at a time at equal distances in the rows. So that helps with attaining that precise placement of seeds within the rows. It also helps, it also has generally a better depth control compared to the air seeders. So the seeds are more precisely placed in row as well as vertically with respect to the depth. These are generally used with the row crops like corn, soybean, sugar beets, but recently some farmers have adopted them for other crops like canola. So we wanted to compare these systems with the conventional air seeding systems and see if they can help with the canola emergence and yield, especially because canola emergence is pretty low in field conditions. It's about 40 to 60%. So we wanted to see if these can help on that front. Generally, the farmers that have adopted their precision or row crop planters adopted these from wide row crops like sugar beets. So they adopted that same wide row system into canola. So we also wanted to compare that wide row precision planting to the narrow row planting and to the air seeding. We used 5 different seeding rates in this study to see how these seeding systems affect the response of seeding rates to plant density or yield. And we found that there was a non-linear relationship between plant density and seeding rate for all of these systems. However, for the wide row planters, those are in the red here, there was a flattening of curve at higher seeding rates for some of the site years. What that indicates is that at higher seeding rates for the wide row planters, there is higher seedling mortality or lower seedling emergence, which may be linked to higher competition in these systems. But for the narrow row planters, there is hardly any flattening of the curve. That is the blue curve here, which indicates that even at higher seeding rates, the emergence was the highest for the narrow row systems. When we average the emergence for all the seeding rates, the emergence was about 1.2 to 1.5 times higher for the narrow row systems. And correspondingly, the plant density was also the highest for the narrow row systems compared to both the air drill and the wide row systems. I wanted to show you a picture of the stands just to give you a visual representation of how they looked with the different systems. These are taken at the same seeding rate and on the same time, same date. And for the air drill, the stands are visually thinner compared to especially the narrow row planters. So there was a better canopy closure achieved with the narrow row planter. And similarly, this picture here, it's an overhead shot of the plots that are placed together for comparison. And in this picture too, especially at the lower seeding rates at 20 and 40 seeds per meter square, the emergence or the stands with the air drill are pretty spotty. But with the narrow row planter, the stands look pretty full compared to the air drill. So there was definitely an advantage to adopting the planters when it comes to the emergence, the plant density, and the canopy closure. But the growth habit in canola is quite plastic. It can adopt pretty well to low plant populations. So we wanted to see if this advantage with the plant populations, does it convert to yield? So under irrigated conditions, there was higher yield with the narrow row planter in 2016 and 2017. In 2018 and 19, the yield for the narrow row planter and air drill was about the same. Overall, there was an average increase of about 10% with the narrow row planter. So under irrigated conditions, it did provide an yield advantage. The wide row planter, it had lower yield for under all the conditions. Under the dryland conditions, the yield response to the seeding systems was a little more dependent on the precipitation. The narrow row planter had higher yield in 2016 and for one site year in 2017. And in 2016, the precipitation was about 15% higher than the long-term 30-year average at Lethbridge and about 70% higher at Medicine Hat. So under high precipitation conditions or under irrigation, there was an advantage to using precision planters. In 2018, though, air drill had higher yield, and for this year, the precipitation was about half the long-term average. So air drill actually did better in these drought years. The wide row planter, it led to lower yield under all conditions. There was a drop of about 25 to 31% in yield with the wide row planter. So based on the results of this study, we don't recommend using wide row precision planters for canola. We recently published this study in the Canadian Journal of Plant Science, and it's an open access. So if you want more information about this study, I encourage you to check this out. We also did a similar experiment with the pulses. For chickpeas, lentils, fava beans, and field peas, we are currently doing a 4-year study. It's an ongoing study. The coming season will be the last year. It's being done at 3 locations in Lethbridge, Medicine Hat, and Tabor. And it's under dryland conditions. And we are comparing the precision planter and air drill, both at narrow row spacing, 12-inch. And the seeding rate for this study is the recommended seeding rates for all of these pulse crops and a lower seeding rate, which is 50% of the recommended rate. This has been an interesting study because for most of the duration of this study, we have had drought conditions. For 9 out of 9 site years, the red bars here are the long-term average, 30-year average at those stations. And out of 9 site years, only 2 site years have actually received about the same as the normal precipitation. 7 site years have had precipitation which ranged between about 45 to 60%. So it's been quite dry for this study. But for the emergence with the precision planters, we definitely saw an advantage to the planters. With the chickpeas, there was about a 30% increase in emergence, with the faba beans about 16%, and with the field peas about 20%. And the increased emergence was also seen in the drought years. So for chickpeas, 6 out of 8 site years showed a higher emergence, and for faba beans and field peas, 4 out of 8 site years. And for the remaining site years too, generally the emergence was the same for air drill and precision planters. So air drill never really led to higher emergence compared to the precision planter for these 3 crops. For lentils though, there was really not much advantage to using precision planter. And the reason might be that the lentils, the seeds are cylindrical in shape, which may not have lent themselves as well to that precision, to that vacuum planting as some of these other pulse crops. But we did see an advantage in case of other pulse crops under drought conditions, and that may be linked to better depth control. In some of these drought years, the surface soils dry out, and with the precision planter, since the depth placement is more regular, the seeds are able to hit that moisture zone more consistently. With the air drills, since the depth placement is a little bit irregular, some of those seeds are not able to hit that moisture zone, and so maybe the emergence is not as much. These are some pictures showing the emergence and also the stand uniformity. So for air drill, there were these huge wide gaps compared to the planter, and that can lead to issues like weed emergence and the resource utilization like moisture and sunlight. They're not utilized to their full. With the planters, we had these nice regular stands. This picture is from another year. This is from 2019. The previous picture was from 2020, I think. Again, showing the same white spots for the air drill. For the precision planter, there's a nice regular spatial arrangement. For the lentils too, although we didn't really see a numerical difference in the emergence, but there is, in terms of stands, there are some wide gaps in the lentils. And then yield, for the chickpeas, the precision planted chickpeas led to higher yield in 3 out of 8 site years. And there was a significant advantage to using the precision planters. Most of these site years were in 2020, which received a decent amount of precipitation, and there was about a 27% increase with the chickpeas. For other pulse crops, the yield advantage was not as significant. For the field peas, 2 out of the 8 site years showed higher yield with the precision planters, and there was about a 5% increase. With the faba beans and the lentils, yield was higher for only 1 out of 8 site years, and about a 50 kgs per hectare increase. However, for none of these crops and for none of the site years, we see that the air drill did not yield higher compared to the precision planter. So in all of the cases, precision planter yielded as much or more than the air drill for the pulse crops. Hopefully we can get a nice precipitation in 2022, and we can hopefully get some good data for high precipitation years. And moving on. To summarize, the precision planters did improve seedling emergence and plant density under most conditions for canola and for most pulse crops, with the exception of lentils. There was a more uniformly distributed crop stands and a more even crop staging with the precision planters. For yield, the yield increased under certain conditions. For canola, it increased under high precipitation conditions or under irrigated conditions. Although with the wide row planter, there was a yield loss under all conditions. For the chickpeas, precision planter yield was higher under more normal precipitation conditions. And for other pulse crops, there was not as significant difference between the air drill and the precision planter. So now moving on to the deep banding of immobile nutrients. We have been practicing no-till direct seeding on the prairies for a few decades now, and that's a great advancement. But with this practice, we do tend to leave all of the surface residues on the soil surface, and it decomposes there, putting the nutrients back into the surface soil layers, and there is no mixing of the soils. So sometimes that can lead to higher nutrient concentration in the surface layers. That's referred to as nutrient stratification. And the idea here was to see if we can put some of the immobile nutrients into the deeper layers where they're more accessible to the rooting systems, and to see if that can provide a crop yield response or more higher nutrient uptake. So this study was conducted at Fleur, Wegerville, and Lethbridge. It was a 3-year study. We banded phosphorus, potassium, copper, and then a treatment consisting of all of these 3 nutrients. And for the banding treatments, we had a shallow banding treatment, which was the conventional banding, where we banded the nutrients with the seed or diagonal to the seed as a band. And the deep banding treatment, which was a periodic treatment in that it was done only in year 1. The nutrients were banded at 3 times their recommended rate, and no nutrient application was done for years 2 and 3. And finally, a control treatment in which there was no nutrient application. These treatments were done for a pea wheat canola crop rotation. And this is a video here, which is showing the deep banding. We used our hoe drill type seeder to band these seeds at about 5 to 6 inch depth. We did this operation in spring, in May, but it can be done in the fall to save time at seeding. We had to do it in spring because of the timing of when the project was approved and the funding was approved. But it can be done in fall. So overall, the generalized results, the big picture was that there was not a huge difference in the shallow and deep banding of nutrients. The response of nutrients, the response of crops to the nutrient additions was muted. It was not high, so it was hard to separate out the effects of shallow and deep banding. And like I mentioned before, we had applied all the deep banding nutrients in year 1. So we didn't really see a difference in crop response with the years 2, because it was possible that with the year 1 3 times application, there might be a higher response in year 1, or there might be a lower response in year 3, but we didn't really see that as a strong or a general trend. We did see some trends at some locations, like for example, at Fleur, for wheat and canola biomass, there was higher biomass in response to potassium, phosphorus, and the PKCU treatment. Again, there wasn't really a difference between the deep and shallow banding. Same thing for yield. Wheat and canola did have higher yield in response to phosphorus-containing treatments, but the deep and shallow placement of these nutrients didn't really make a difference. We also measured the nutrient content of seeds and biomass to see if there was better uptake with these banding treatments. Again, there was a lack of strong and consistent response to the deep and shallow banding treatments. This is one example where there was actually a difference. For canola, the phosphorus biomass content of phosphorus was higher for the deep banding treatment, but this is 1 out of 27 different possibilities. So in general, we did not really see a consistency in these responses. So the summary is that there was an occasional response, especially to the phosphorus-containing treatments, but it did not really link to whether these were deep or shallow placed. And overall, either method may be considered really depending on farm logistics. The deep banding does need an extra pass, and that may mean extra energy and extra cost, but it can save time at seeding. The shallow banding, it saves energy, saves time, and it also avoids soil disturbance. So it really comes down to farmers' preferences. Finally, I'd like to thank our funders and partners, and especially the team at Farming Smarter, Mike Kretzinger, research coordinator for these trials, and thank you all. And do we have time for questions?
All right, we've got a question. Go ahead.
With the deep banding, 1 year and 3 different crops in 3 different locations, how did your rates change to accommodate the different?
The difference in rates for the crops?
For the deep applied nutrient, for the different locations, different soil types, different yield potentials, did you vary the applications?
Yeah, we did soil testing prior to all the crops, and the rates were dependent on the soil tests. That answers your question.
Did that answer your question, kind of what you're looking for? You were wanting to know if the individual conditions were taken factored into the results then?
Yeah, I think, well, the rates of the fertilizers depended on the soil test, and the statistical analysis was done separately for separate conditions. So in a way, the differences in growing conditions were taken into account at the time of the statistical analysis.
Is there anything? I'm thinking, yeah, like we did a background test at every location, so we would have I think we had our own rates for each of them. That's what you're kind of getting at. I mean, in Lethbridge, we're not really deficient in copper, but obviously in the Peace and Vegreville region, they have different deficiencies. So we had to kind of choose common nutrients that were both immobile and non-immobile, and so we kind of had to make it work for all sites, but we used our own analysis to put it all together, if that makes sense.
And that was one of the reasons, actually, to go for copper, because we didn't really expect to see a response here, but up north, there were some. They did want to test it. So.
Okay, we've got a couple of questions at the back. We'll go to the farthest back and then come back there. Okay, go ahead.
It appeared from here as though you didn't have much difference between your check and your treatments on a number of the sites. Was that my eyesight from back here, or was that real?
No, that's true. We for many of the site years, we didn't really see a response, especially to potassium and copper. We did see some response to phosphorus, which is expected. Where we did see a response, generally did not change with the deep and shallow banding.
Okay, and your question?
Were the nutrients not included in the trial all supplied in abundance in the trials?
Sorry, can you just repeat that?
Oh, so to make sure that, for instance, nitrogen wasn't limiting or
Okay.
boron wasn't limiting, were all the nutrients not evaluated in the trial supplied in abundance?
Yes, for sure. Nitrogen was applied at recommended rates depending on the background test.
And so, other nutrients?
And then I did have one other quick question on your seeding rate trial. On the air seeder compared to the planter, were the depth control systems the same?
The depth control on the precision planter is better. It has the parallel linkage, so and that might have played into the results. That on the air seeder, the depth control is not as good, I think.
Okay. One more quick question.
Two items. What kind of air drill was it? Was it a shank or a disc? And the other question is there a possibility of seed damage being different for the air drill as compared to the precision planter?
It was a disc drill. The seed damage, it's an interesting question. I don't expect that to begin. Maybe can.
Not an R seeder. It's not like a regular air seeder with manifold, so I would suspect there's limited damage on those.
Okay. Great discussion. I think it's probably one that we can continue over lunch. Let's thank Gurbir again. Thanks for bringing us that research.